In this video, we're looking at the idea of the work done by a force. And there's a very simple relationship. For a force that is acting in the direction of motion, the work done is equal to the force times the distance. And force is measured in newtons, distance in meters, and so the units of work are Newton meters. 1 Newton meter is equal to 1 joule, and the joule is the standard unit that we use for work and for energy. Because of the numbers involved, very often we have very large numbers of joules, and so it's useful at this stage also to know that 1000 joules is 1 kilojoule. I mentioned at the beginning that the work done relationship is for a force in the direction of motion, and of course that isn't always the case, and sometimes we have to use the component of a force in the direction of motion. So take for example a package being dragged across a floor by a string that's inclined to the horizontal as shown in the diagram. In this case we've got motion only horizontally, and so only that component of the pulling force that is in the direction of motion will be doing work. The other component in the vertical direction, because there's no movement, will be doing no work, and so we would have to find the component of T horizontally to use with the distance dragged along the floor. In other cases we look at the distance moved in the direction of the force. Take for example this box that is sliding down a smooth slope. There are only two forces, the normal reaction and the weight W, and it's travelling a distance x down the slope. In this case, the work done by the weight W, we can use the height through which it has travelled to be the distance in the direction of the force. And so in this first example, very simple example, we've got a package pushed 10 meters by a force of 7 newtons, and so the work done, which we're asked to find, will simply be the force 7 times the distance 10, 70 joules. For this example, pause the video for a moment or two and read the question carefully, and then try to draw the diagram of the situation. You may have something like this. You may have included the weight and the normal reaction, but they're not relevant to the actual motion, so I've left them out of my diagram and just shown the pulling force P and the resistance. Now the work done is going to be equal to the force times the distance. In this case we're told the amount of work done, 54 joules, and that's equal to the pulling force P times the distance 9. And so P will equal 6 newtons. Crucially, in this question we're told that the box is pulled at constant speed, and therefore the resistance is exactly balanced by P, and so the resistance is also equal to 6 newtons. This third example is about 200 kilograms of bricks which are being lifted 12 meters to the top of the scaffold, and we're asked to find the work done in lifting the bricks. What we need to look out for here is that we're given the mass and not the weight, and remember that for work done we need to be working with a force, and so we have to turn the 200 kilograms into a weight. So the weight will be 200 times G, and therefore the work done will be 200 G, the weight, times the distance 12, and that works out to be 23,520 joules. And here's our first opportunity to write an answer in terms of kilojoules. So that would be 23.52 kilojoules. In this final example, pause the video and read the question thoroughly, and then have a go at doing the diagram showing all the forces relevant to the problem. Your diagram should look something like this: a pulling force and a frictional force, the weight of the object and the normal reaction. In this case, to begin solving the problem, because there is friction, we need to work out the normal reaction, and of course that is going to be looking at the forces vertically, that R is equal to 8G. Therefore, the frictional force F will be equal to 0.4 times 8G. Now, in order to use our work done is equal to force times distance, we need to know the distance travelled. We're told that the speed is 5 meters per second. We're interested in 3 seconds, so the distance will be equal to 5 times 3, 15 meters. And the work done against friction is the actual frictional force, which is 0.4 times 8G times the distance of 15, and that works out to be 470.4 joules.